This short video is about the tutorials of the INDIGO-DataCloud LBT use case. This training material is available through the OpenEDX learning platform. After login, the user can access the Introduction to Indigo Solutions online course. The course is structured into 4 units: Introduction, Building a Cloud Application as Software as a Service, Managing Infrastructures, and Applying Indigo Tools in Research. This section is about the LBT use case. First, there is a brief introduction about the LBT use case requirements, describing how data must be distributed through different geographically distinct sites. Then we have the OneData tutorial to manage data distribution, and the Ophidia tutorial for the astronomical image calibration tasks. Going back to OneData, the user can access the GitHub repository and clone the repository on its own machine. The tutorial is structured with an introduction about OneData and its most important concepts, spaces, providers, and zones, and how it can be used to satisfy LBT distributed archive requirements. The first step of the tutorial is the OneData deployment, and we have created a pre-configured virtual machine with everything ready to mimic the real situation to distribute data on different sites. Otherwise, the user can deploy OneData manually, and we provide all the details about configuration, firewall rules, installation requirements, Python packages, etc. The second step is about using OneData. We have created the ODLBT OneData LBT package to help the user to configure and use OneData within the LBT use case. The tutorial covers all the aspects of the management of an astronomical distributed archive with OneData: user creation, data upload, metadata management, etc. The tutorial is quite long, about 1 hour, so we now show some operation the user can do inside the virtual machine. Here the user is deploying the LBT zone. In a similar way, he can deploy the Trieste provider and the Heidelberg provider. After deploying OneData components with a web browser, the user can log in to the LBT zone. At this point, we are at an advanced stage of the tutorial where OneSpaces have been already created, and the data of the INAF partner have been already uploaded. We provide a lot of documentation. We added also help comments for the user that want to explore all the features of OneData. Going back to the tutorial, in the conclusion we have a feedback questionnaire to collect user opinions about the tutorial. Then we go back to the course page and the Ophidia tutorial. This second tutorial is about astronomical image calibration tasks with Ophidia. The goal is to elaborate the raw image acquired at the telescope on the left to get the reduced science-ready image on the right. Also in this case we have a GitHub repository, and the user can clone it on its own machine. In the tutorial introduction, we provide details about Ophidia and Ophidia Lab, the science gateway to use Ophidia from a web browser. In the first sections, the user learns to use the Ophidia terminal and becomes familiar with the Ophidia syntax. Then we describe the astronomical image calibration process. We start from the raw image of the NGC 5364 spiral galaxy, very noisy, and we want to clean it, using standard astronomical techniques: flat, dark, and bias frames. We prepared a Jupyter notebook to guide the user to perform astronomical image calibration with Ophidia. After login to Ophidia Lab, the user uploads the notebook and runs it. The Jupyter notebook contains both description text and Python code that the user can run with the run button. Going on with the calibration process, for example here, the user is loading the filters to use, defining the observation types, and he computes the median for the bias frames. A Jupyter Notebook is very flexible, and it allows the user to edit the code. Here the user is setting up custom filters and run again the data reduction process to get custom results. Also, this tutorial is quite long, about 40 minutes, so we jump to the end, where output files are created. And they are available in the Ophidia Lab page, ready to be downloaded. The final result is like this image, where the faintest details like the spiral arms are now clearly visible. Last consideration about performance, and also in this case we have a feedback questionnaire.